Hello everyone. In the previous session, we discussed about portable or in vivo diagnostic devices part 1. In this session, we are going to discuss about portable or in vivo diagnostic devices part 2. Under that, we are going to discuss about three major equipments. Number 1, Spigmo Manometer, number 2, pulse oximeter, and number 3, electrocardiogram. Now let's see about the first equipment, Spigmo Manometer. Under this, we are going to discuss about its introduction, working procedure, types of Spigmo manometer, components in it, and the significance of blood pressure measurement. Spigmo manometer is an instrument used to measure blood pressure of a patient. It is otherwise referred as blood pressure apparatus, blood pressure monitor, or blood pressure gauge. The word Spigmo manometer is derived from the Greek word spigmos, which means beating of heart or pulse, and manometer, which is a device used to measure pressure or tension. So this instrument was invented in the year 1881 by von Bosch, and this is further simplified by Rivarocki in the year 1896. There are two readings in the blood pressure measurement, systolic and diastolic. The normal reading is 120/80. When the doctor puts the cuff around the arm and pumps it up, he or she is trying to cut off the blood flow with the pressure exerted by the cuff. As the pressure in the cuff is released, the blood starts flowing again. The number at which the blood starts flowing again is the measure of maximum heart pressure, and this is otherwise referred as systolic pressure. The doctor continues releasing the pressure until he hears no sound. That number is the minimum heart pressure, and this is otherwise referred as diastolic pressure. There are different types of sphygmomanometer: mercury sphygmomanometer, aneroid sphygmomanometer, and automatic digital sphygmomanometer. Now let's see about mercury sphygmomanometer. Mercury sphygmomanometer is a conventional blood pressure apparatus, and it is considered gold standard. The instrument consists of manually inflatable cuff connected to the mercury filled tubes. In order to acquire the correct reading, the apparatus has to be placed on a flat surface and in an upright position. If the instrument is dropped accidentally, there are high chances of risk. The advantages of this instrument are easy to use and it need not be recalibrated. Due to its toxic contents, this apparatus is banned in few countries. Now let's see about aneroid sphygmomanometer. The term aneroid means without fluid, and in this instrument there is no use of mercury. It consists of a stethoscope connected to a cuff, which in turn is connected to a dial gauge. To convert the cuff pressure into a dial pressure, the dial head has got mechanical part. The instrument has to be recalibrated to avoid faulty readings. There are different types of aneroid sphygmomanometer based on their different uses. They are pocket aneroid sphygmomanometer, palm aneroid sphygmomanometer, and clock style aneroid sphygmomanometer. Now let's see about automatic digital sphygmomanometer. Automatic digital sphygmomanometer are the most technologically advanced sphygmomanometer. It consists of a electrical sensor to measure the blood pressure, and the readings are displayed on the digital monitor. To measure the blood pressure, the instrument measures the fluctuations of the arteries. These sphygmomanometers has to be cross-checked with the normal conventional mercury sphygmomanometers in order to avoid inaccurate readings. The next component is manometer. Manometer is a device used to measure the pressure or tension in mm of Hg. There are different types of manometers that are specifically used in different types of sphygmomanometers. The next component is valve. This is helpful in deflating the cuff. In order to acquire the accurate reading, the valve is an important component. The next component is bulb. This is helpful in inflating the cuff. Here is the significance of blood pressure measurement. The blood pressure measurement is done in terms of systolic over diastolic pressure. The normal representation is done as 120/80. The blood pressure sounds are referred as Korotkoff sounds. Blood pressure is measured in terms of mm of Hg. A normal blood pressure is considered below 120 for systolic pressure and below 80 for diastolic pressure. Hypotension, blood pressure below normal, that is below 120 and 80, is normally not considered a problem. In contrast, hypertension, a pressure above the normal blood pressure, is normally considered a problem. The next portable or in vivo diagnostic devices we are about to discuss is pulse oximeter. Under pulse oximeter, we will see introduction, working, types of pulse oximeter, components in pulse oximeter, probe positioning sites, and significance of SpO2 measurement. Oximetry is the measurement of oxygen saturation in hemoglobin. Pulse oximeter is an electronic device used in vivo and continuous measurement of hemoglobin oxygen saturation. It is referred or denoted in terms of SpO2, and this is otherwise referred as fifth vital sign. Now let's see about the working procedure of a pulse oximeter. The pulse oximeter depends on the spectral analysis for the measurement of oxygen saturation, that is the detection and quantification of a component in a solution by its specific light absorption characteristics. The pulse oximeter combines two technologies, that is spectrophotometer, through which it measures the hemoglobin oxygen saturation, and optical plethysmography, through which it measures the pulsatile changes in the arterial blood volume at the sensor site. When light passes through a matter, it is transmitted, absorbed or reflected. The relative absorption or reflection of light at different wavelengths is used in this device. This type of measurement is called spectrophotometer. Here it is based on the Beer-Lambert's law of absorption principle. There are two types of pulse oximeter: transmission pulse oximeter and reflectance pulse oximeter. The transmission pulse oximeter is a commonly used type of pulse oximeter. In this, the light beam is transmitted through a vascular bed and it is detected on the opposite side. Reflectance pulse oximeter relies on the light that is reflected by the vascular bed. In reflectance pulse oximeter, both the LED and the photodetector are placed on the same side. Now let's see about the components of a pulse oximeter. Probes are the major component of a pulse oximeter. Probe is a part which comes in contact with the patient. Probe contains one or more LED that emits light at a specific wavelength and also a photodetector. There are several types of probe, especially reusable and disposable probes. The second component is cable. The probe is connected to an oximeter with the help of an electrical cable. Cables from different manufacturers are not interchangeable. The third component is console. Many different consoles are available. Mostly in an operating room, the consoles are a part of physiological monitor. Consoles of a pulse oximeter are also freestanding units. Small, handheld, battery-operated pulse oximeters are often used especially in terms of transport. Probe positioning sites for pulse oximeter are fingertip, toe and nose. Fingertip is a commonly used site. Failure rate is less and accuracy is high when compared with the earlobe. Toe is an alternate site when the finger is not available or when the signal from the finger is not satisfactory. Nose is usually a convenient location and it responds more rapidly to the oxygen saturation when compared to the probes placed in the extremities. Here is the significance of SpO2 measurement. Oxygen is tightly regulated within the human body because hypoxemia may lead to acute adverse effects on individual organ systems. Pulse oximeter has provided a convenient, continuous and non-invasive method to measure oxygen saturation. Generally, the level of oxygen saturation at resting state should not be less than 95%. The next portable or in vivo diagnostic device we are about to discuss is electrocardiogram or ECG. In electrocardiogram, we will discuss about its introduction, working principle, components of an ECG, normal ECG wave and significance of an ECG measurement. Introduction. Electrocardiogram machines or ECG devices are instruments used to measure the electrical activity of the heart and to detect the abnormalities. It is highly beneficial in detecting cardiovascular diseases. As it is one of the safest and least invasive technique, it is utilized by millions of cardiologists all over the world. The ECG is depicted in the form of electrical waves. These waves vary in according to the health condition of the heart. Now let's see about the working of an ECG machine. It works on the principle that contracting muscles generate small electrical current that can be detected and measured by the electrodes placed suitably on the body. For a resting ECG, the person is made to lie in a resting position and the electrodes are placed on the arms, legs and at 6 places on the chest over the area of heart. The electrodes pick up the signal and transmit them to the amplifier inside the electrocardiogram machine. The ECG machine then amplifies the signal and converts them and traces them in the form of wavy line. The major components of electrocardiogram are electrodes, amplifiers and output devices. The machine comprises of a set of leads with the metal discs at the end of the wires. These metal discs are soft and adhesive and can be placed on the surface of the arms, legs and chest. Majority of ECG utilizes 12 electrodes for the measurement of electrical activity of heart. A special jelly is used to maintain the impedance difference. Amplifier is a device used to acquire the electrical activity from the electrodes and it then amplifies the signals. The amplifier includes buffer amplifier and preamplifier in order to convert the information, and that can be read by the different output devices like recorders, computers, magnetic tapes, oscilloscopes and so forth are available and can be opted based on the requirement. A normal ECG makes specific pattern of 3 recognizable waveforms in a cardiac cycle. They are P wave, QRS wave and T wave. P wave indicates atrial systole. QRS represents ventricular systole and atrial diastole. T wave represents ventricular diastole. Different color codes represented in the picture helps to relate the conduction system of the heart with the normal ECG waveform. Significance of ECG includes diagnosis of irregularities in the heart, record changes in the heart activity, etc. The ECG is of critically important in diagnosis of acute myocardial infarction, tachycardia, bradycardia and so on. Now we have come to the end of the session. Hope you all understood about portable or in vivo diagnostic devices part 2. In the upcoming session, we are about to discuss about medical imaging devices part 1. Thank you.